Steve is calling.
Tablebot, or Tbo as we've been calling it, is part of a class of robots that we've been developing that we're calling situated robots. And what we mean by that is that these are robots that essentially hide in plain sight. We're interested in questions that an architect, for example, might be interested in. Questions of spatiality, questions of human scale. Essentially, these are robots that are integrated into the built environment, into the furniture, into the objects that are around us. This provides an opportunity to make the interface disappear as much as possible and to only appear when it's called upon. Tbo, or Tablebot, includes functionality of telepresence, so you can talk to people at a distance, and also it works as an AI assistant, so it becomes a portal to a much larger world. What we're trying to do here is create a portal that allows the user to connect to other people via telepresence and to connect to the internet via an AI assistant-like capability. We want to make these interfaces as inconspicuous as possible. And we feel we can do that by integrating these kinds of robots directly into the furniture around us, into the built environment.
For Tbo, this meant making it like a table as possible. The design choices made, such as the all-wooden outer cylinder and many others, gives it an inconspicuous look of a table. However, its internals are packed with technology. We also wanted the interaction with Tbo to be just like interacting with a real table. For example, if you push Tablebot from behind, it moves exactly what you would expect a real table to move like. Tablebot is also a new kind of a virtual assistant platform, and we plan to develop this into a family of situated smart connected robots. Unlike Google Home or Alexa, which are spatially fixed, we believe Tbo's capabilities to move around expands its capabilities considerably. In addition, we envision Tbo to be a base station, if you will, to a group of other situated smart robots. For example, Tbo can generate a 3D scan map of the room and relay that information to other robots, all communicating in real time. We believe making Tbo do the computation-heavy tasks allows other situated robots to be both power efficient and cheaper to build.
In order to navigate through the room without human control, the Tablebot uses a technique called simultaneous localization and mapping to navigate autonomously. Using this technique, it uses a depth sensor mounted on the front as well as sensors internal to the drive base that allow it to figure out where it is in the room and build a map, so to speak. Later, it can use this same map along with sensor data from the same sensors in order to figure out where it is at a later time and move to different points throughout the room. We want to, in the future, improve the accuracy of path planning as well as potentially extend SLAM so that we can make maps on this robot and use it in other situated robots, as this robot already has the processing power to do so.
In addition to their ability to move about the space, users can beam into these objects to create connections between people and space. Because Tablebot is mobile and equipped to project onto almost any surface, the telepresence experience is different from others. Using projectors rather than screens, the experience is less Skype on a stick and more an embodied, immersive experience.